This goes along with our poster over here with Unit H of your key standards. We've done the add subtract right now with the polynomials. We're going to be doing the multiplying part. That's going to be the other key standard on the test. And then the last part will be the rewriting. Okay. So today we've done some of the rewrite because we've done the factoring form of those first ones when we were doing H2. So now again we want to keep in mind, it says in the last lesson you use the distributive property to multiply. If we are looking at another monomial, we can look at it another way. So as we are looking at these two, we might have a problem like this. So we're going to be multiplying larger polynomials. This is a trinomial times this is we just call it a polynomial, right? So we have 3 terms times one that has 4 terms. It says when multiplying larger polynomials, using the distributive property to organize your work is important since there's lots of combinations of terms that need to be multiplied together. So as you are looking at these, there's going to be several different methods of organizing your work that we're going to be learning today. You should be familiar with all of them on the test. You can choose whichever one you want to do. I'm going to show you some different methods. Some of them is just simple distributive property. Other ones I'm going to show you like that box method that you looked at. And then we're going to come up with kind of some names that we call some that if you talk to older people, they go, oh yeah, you're using this property. So one of the key things it says as you're multiplying polynomials is to a simpler form is you are going to be thinking you're going to take this 2x, notice they wrote that, and then they put that second parenthesis 3x minus 7, and then they put a plus 4. Where'd they get the plus 4? That was the second term in that first binomial. And they put a plus 4 and they're taking it times 3x minus 7. So using the distributive property, that's how they got 6x squared minus 14x. Then they're going to take 4 times 3x and the 4 times negative 7. And now you're going to add your like terms. And the 2 terms that will usually be like are these 2 inside terms, negative 14x plus 12x to get negative 2x. So I would like you to do this one in the same way. It says draw the arrows to make sure that you multiplied every pair of terms. So if we are writing this problem, next step down, and I would recommend going down with your problems instead of across, we're going to put x times what? 4x plus 3. And then I'm going to put either a plus negative 6 or a minus 6. So writing this in your notes, please. And we are going to take negative 6 times 4x plus 3. As I am doing that, as I start multiplying, Soren, what are you going to get for this first one if I am showing those arrows?
4x to the second.
4x to the second plus Kylie. We're taking x times this second term here.
Minus
18. 3x. Then we're going to continue, and if we're going over here, Gavin, I'm going to have what?
Negative 24x.
Negative 24x. And if I continue, Caden?
Negative 18.
Just negative 18. So you want to write down all of these. Don't skip the steps. Please show all of this. And these are our like terms that can be added together. So at this point, we have just a polynomial, but it's going to simplify to 4x squared. Adding our like terms as I add those, Abby, I'm going to end up with, Abby Lynn, minus 21x, and then I have minus 18. If I was asked, is this in standard form?
Yeah.
Yes, this is in standard form. So this one is in standard form because we go from the x squared to the x to the first to our constant term, right? So this is in standard form. Okay, so if on the quiz today, I ask you to put, after you've multiplied out like we did at the beginning of the lesson on H2, in standard form, that means going from descending order. That means the largest exponent to the constant. And if I ask you to name this one, please write down the name right now and then I'm going to call it. Name should be looking at the degree and how many terms. So you're always looking, what is the degree and how many terms, okay? So if I'm looking just at the degree, Abby, I'm going to have it called a what kind? Because it's a 2 here. Not a square term, but we call it it has a special name. You want to turn back and look at that H1 notes. Hang on. Yep, that page right there and that table on the top. If it's a second second degree. Look at the degree part for a 2 second. It's going to be quadratic. And thank you, I only needed to do the first half, but I appreciate that. Quadratic and not a binomial, Elena, but a what? Trinomial. Okay? 3 terms, right? So quadratic, trinomial. Okay, so naming it. My hint would be, as you're doing some of your homework, practice doing the naming, especially if you did really poorly on that quiz. Okay? Now, this might remind you of multiplying in elementary where you did that lattice multiplication. What? I am not a huge favor of that, but this for a lot of you will help you to organize. So notice, you're going to put x plus 2, so you're going to put this box, and then you're going to put 3x squared above the first box, minus x and plus 7. You are going to multiply each of these. So I'm taking 3x squared times x gives me 3x to the third. I'm going to take 3x now times the 2. 6x squared. I am now going to go to this next column where I had negative x. Negative x times x is going to give me, if I'm looking at that, lady, negative what? If I take x to the first times x to the first, I'm going to get x to the second. So I'm now going to take negative x, Caden, times 2, negative 2x. I'm going to continue with my multiplying. Dylan, if I'm taking 7 times x,
7x.
7x. And Jack, multiplying the last one, 14. Now, why is this nice? Because along each diagonal. So my answer, I don't have any other like terms. I'm going to have equals 3x squared. I'm going to add these two along the diagonal. 6x squared minus x squared, Mallory, which is going to give us 5x squared. Taylor, we're going to add along this diagonal, because I have more like terms in this one. Negative 2x plus 7x plus 5x. And then I have nothing else to add with the 14, so I have plus 14. And my mistake was, no one wanted to correct me if some of you saw it, maybe you were trying to raise your hand, x to the third, right? So if we're naming it, Maria, by the degree, only the degree. Don't tell me the number of terms, just the degree. It would be cubic, right? So this is going to be cubic. Is it in standard form? It is in standard form. And we would call it a cubic just polynomial, because it's more than 3 terms. Okay? Cubic polynomial. Okay? So some people like to do this one, so I would, some people like that other method of writing it out. This one, I want you to draw that box. Okay? We have to have like a rectangular box, and you need to have 2 spaces on the top. Does it matter if I put 3x plus 1 on the top or on the side? No, it doesn't matter. I'm going to put my 3x, and I'm going to put a plus 1. I'm going to put x. And you don't even have to put the plus 4, but you do definitely want to put in the minuses. Okay? So if we are going to continue as I'm multiplying this on, I'm going to have, what as I multiply my first? Actually, I'm going to have you guys try it, and then I'll fill it in. Okay? So I want you to try it first if you haven't filled yours in. Start there. 2 going down.
First 2 going down.
Yep.
3x squared.
Yep.
And 12x.
And 12x. Josie, if I'm going to do the next 2.
Probably 1x and 4.
And again, you don't have to put 1x if you're looking at that. So now as we add along that diagonal, Liz, my answer is going to be?
No, just 13x.
Should it be 13x squared?
12x squared.
It would be 12x squared. No.
13x.
So,
13x.
Oh, we don't add the exponents. Remember the nothing when you're adding x plus x, you're adding 12x plus 1x. Only 13x, not an x squared. Because if it would have been x squared, then I would have had to add those 2 together, right? So if I'm looking at this answer, then telling you by the degree only the degree, what kind of polynomial, or how would you name it? Quadratic. And then, reckon if we, after we have quadratic, we'd have what would be our number of terms? What would be the vocabulary we'd use? Trinomial. Okay. Now, later in this unit, we are going to start with this, and that's what the third standard is up on the poster, and you're going to work back and get this answer. So, keep in mind as you're doing these problems that as you multiply, later in this unit, we're going to try and work backwards. That's going to be the key thing of understanding. You have to be able to do it multiplying, and then you have to be able to work backwards and get that factor, okay? And by the time we get to that, that's going to be a little later in the second half of this unit, but that is our kind of goal as we are looking at this. So on that next page going down, they talk about another method of multiplying, and this is called the FOIL method, okay? So some people like to come up with different names or ways of remembering things. So FOIL is simply an acronym. It helps you to remember that the pairs are terms that must be multiplied when multiplying your two binomials. This only works if you have two binomials. So if we are looking at it, it stands for the first two things in each parenthesis, the 5x and the 2x you're multiplying. The outside things in both parentheses. So you can see the blue arrow here, the outside, the 5x and the 1. Next, you're looking at the inside pairs. That's the innermost things in both parentheses. That's the -3 and the 2x. And then the last thing in each parenthesis, which is your -3 and your 1. So then you're simply multiplying them together. 10x squared plus the 5x minus 6x minus 3. And then you have to add, and it's almost always your two middle terms that you'll add to get that -x. And again, if we were going to name this, so our answer would be 10x squared minus x minus 3. This is another quadratic trinomial. And again, later in this unit, our goal is I'm going to give you this for a question and ask you to come up with this that we're going to be factoring. Okay? This is going to be really important as we go into our next unit when we do the factoring and multiplying when we have our quadratic. So if we take a look at this one, we want to use that FOIL method. So if I'm using that FOIL method, Emmy, start me out with my first would be what? The first in each parenthesis, 3x times x. So this is my first, so that's 3x times x. Then I am going to put, Jacob, what? And I'm going to go to plus, and I'm going to put 3x times 2. So that is my outside of each one, okay? Micah, I'm going to continue. I now want the inside of each parenthesis.
-4 times x.
-4 times x. And then I'm going to do my last of each parenthesis, which, Whitney, would be what? -4 times 2. So 3x times x, 3x squared. 6x minus 4x. Can I put right away, instead of writing 6x minus 4x, can I put that sum, which is, or difference, which is 2x? Yes. Those are my like terms, right? 6x minus 4x. And then I have a minus 8. Okay? So, the next problems, I would like you to try doing whichever method, and I'm going to have people come up and put them on the board after you've done them. So, put the names, and as you are looking at those, and then as we look at this one, so it says, as we look at this last problem, it says, what is the total surface area of a cylinder with a radius of x plus 2 and the height of x plus 4? Write your answer as a polynomial in standard form. Leave your answer in terms of pi, so it will be exact. It says, here's the formula for surface area. Surface area equals 2 pi radius squared plus 2 pi radius height. So first thing we might want to take a look at is that 2 times pi, and we're going to put in our radius, which was x plus 2. And then we are taking it times our radius, which was x plus 2, right, in the formula, and then our height, which is x plus 4. So now it says we're going to substitute in those lengths in our picture. We are now going to be looking at multiplying those. So when I start doing that, we want to multiply this out. So we're going to put surface area is equal to 2 pi. What is, when something is squared, when I have x squared, what does that mean? How many x's? That means x times x, right? This says x plus 2 squared, which means x plus 2 times x plus 2. This is not x squared plus 4. X plus 2 squared is not equal to x squared plus 4. There's a middle term. Okay, so that's a real common mistake. And the second one, we're going to leave the 2 pi, and we're going to start multiplying that. So 2 pi, and if we start multiplying that second one out, we're going to have 2 pi. X times x gives us x squared. X times 4 is 4x, right? Plus 2x plus 8. X times x gives me x squared. That's my first. Outside was 4x. Inside was 2x. 2 times 4, 8. Okay? I'm going to do this x squared plus x plus 2 squared now. Okay? I'm going to keep the 2 pi out in front. So surface area equals, I'm going to keep 2 pi x times x, if we are multiplying that. Kate? Caleb? X squared. Do you want to give me my second term? So outside,
Would be 2x.
2x, Sanjay. My inside would be 2x. And if I am looking at the next one, Soren,
4.
plus 4. I have this 2 pi, right? And they ask us to leave our answer in terms of pi, standard form. So 2 pi, I'm taking times, can I add any like terms in here
Yeah.
to make it simpler? X squared plus what? 6x plus 8. And we could have added these two together too. So 2x plus 2x, right, is 4x. Notice that if you have x plus 2, that whole thing squared, this comes out to be the square of x. This comes out to be multiplying these two together and doubling it. That's 4x. And the last one is the square of the 2. So x squared plus 4x plus 4. This is going to help you later when we have to factor. But now we're taking 2 pi times everything. So I start multiplying by 2 pi, Kylie, and I'm going to have what?
2 pi times x squared.
Yeah.
Plus 2 pi times 4x.
Which gives us what? 2 pi times 4x. 2 times 4 gives us
8.
8. X and then pi, right? Or pi and x, doesn't matter. So this first one we might want to write as 2x squared pi, right? We have 8x pi, and then my last one, Gavin, in that parenthesis should be
8 pi.
8 pi. Okay, Kate, you ready to continue with the next parenthesis? We're eliminating those parentheses. 2 pi times x would give us x, 2 pi x squared. And we're going to notice that we put all of our x squared, or our x's first. We're going to go 2x squared and then put the pi behind it. Okay, Abby, if you continue. You, please. Please, plus 12x and then pi. Okay. Taylor, if we go the next one, 2 pi times 8, that last one,
16 pi.
plus 16 pi. So the next step, combine our like terms. Mallory, which ones can we start adding together? 2x squared pi and 2x squared pi. What do you get? 4x squared pi. Jack, I'm going to continue adding my next like terms. 8x pi and what else? 12x pi gives us how much? 20x with pi. And if we are looking at our last one, our like terms, if we add that, this should be 16 pi, right? Okay. So if we look at adding our last like terms, Dylan, what are you going to end up with?
24 pi.
Plus 24 pi. Is it in standard form? Highest degree to the lowest degree. Keeping in mind that pi is simply a number, right? It's irrational, but so we keep it exact in a problem like this. Because if you were actually figuring out how to make this out of aluminum or out of some type of metal, this can for the surface area, like a soup can, you want to be exact with your measurements, so you're going to keep everything in terms of pi until that very last answer as you look at that. Now, I know we didn't get a lot of time for you as you're looking at your work tonight, so that G5 assignment